Okay, this is the P2 paper from June 2023. It's question number 8, and this is a proof question. We want to do one of them by counterexample, and we want to do one of them by exhaustion. So let's have a look at part 1 first of all. Part 1 says, student writes the following statement: when A and B are consecutive prime numbers, okay, A squared plus B squared is never a multiple of 10 if A and B are consecutive prime numbers. Show that by counterexample this is not true, so you've just got to plug some numbers in and find a counterexample. So 2 squared plus 3 squared would be 2 consecutive prime numbers. I'm starting with the very smallest ones. That's 4 plus 9, which is 13. No, that doesn't work. Next 2 consecutive primes will be 3 and 5. 3 squared plus 5 squared, well, that's 9 plus 25. No, that's 34. That's not a multiple of 10. 5 squared plus 7 squared. That works out to be 25 plus 49. No, that doesn't work. And then next one, 7 squared plus 11 squared. That's 49 plus 121. And 49 plus 121 makes 170, which is a multiple of 10. So 170 is a multiple of 10. Therefore, the statement is false. Therefore, statement is false. Yeah, when we're doing the counterexamples, normally they happen within 4 or 5 goes. Otherwise, I'd be looking at trying to think about it and seeing whether I'm missing something, and maybe it needed to be. For example, with prime numbers, sometimes the 2 is the only one that actually works for a set of a particular scenario. But yeah, that came out quite easily. Part 2, given that x and y are even integers greater than 0. Okay, that's quite a limit, and less than 6. Even integers are greater than 0 and less than 6. There aren't many of those. Prove by exhaustion that this fact, 1 is, or x squared minus xy over 4 is between 1 and 15. We can do it literally by doing all the possibilities. So part 2 takes a bit of thinking about. The very first time I did this, I wasn't sure. And then you said, well, no, actually, if you just set x and y, and then you set x squared minus xy over 4 and get the answer to it, for even integers bigger than 0 but less than 6, you could just say, well, that's an even integer, so what can I have? I can have it with itself, I can have it with 4, that's it for 2. With 4, I can have 4 with 2, I can have 4 with 4, and then that's actually all the possibilities for even integers that are between 6 and no, it's only 2 and 4. So those are all the possibilities. Let's just work those out. So x squared minus xy over 4 for 2 and 2 works out to be 3. For that one, it works out to be 2. For that one, it works out to be 14. And for that one, it works out to be equal to 12. So we've done it. We can just make it really, really clear what we've done here. So 2, 3, 12, and 14 are all between 1 and 15, therefore proved. So I won't go into any more detail than that. So yeah, these proof questions, we're getting more and more of them now from when it was a new topic. So just make sure you've seen every different type. There's lots of different methods of proof that we need to be aware of. But hopefully that's a fairly straightforward one, and add that into your knowledge bank. Okay, hopefully that makes sense.